Alright, so we're doing 2.2. We're going to talk about limits involving infinity. So instead of it approaching a number, we're going to talk about what happens when it approaches infinity. Okay, so we're going to find the limit of sine x over x as x approaches infinity. Yesterday we found it as it approaches 0. Now we're going to find it as it approaches infinity and see what happens. First thing we're going to do is graph on a graphing calculator. So take out your graphing calculator. I'll show you what it looks like. Okay, then we want to graph sine x over x. So, Christian, since you want to hear your voice on the video, walk me through this. What am I going to press to graph sine x over x? What? Before that. Where do we enter equations at? Y equals. So we press that first. If I have something there, what do? I hit clear. Right, so you don't freak out, throw your calculator away. Press the clear button. And then what? Good, sine x. And then? And then? Open or closed? Okay. So what button do I press? Divided by x. Any questions with that? Okay, now what?
You go to the graph.
Okay, you hit the graph button. Alright, that graph looks crappy. All Christian's fault. Aaron, what do you do to fix it? Help him out. I can't see anything.
Oh, that is all you have to do is press zoom.
Okay?
And then, pretty sure you can just put zoom in. So
Alright.
Press 2 if you want.
Okay, press 2 if I want. Now what?
And then press enter.
Good.
Now it looks great.
Now it looks a little better. Now, what are we looking at again? The limit as x approaches what? Infinity. What do we have up there? What is x going up to in this graph? It's going up to like 2, 2.5 maybe. Is that close to infinity? No. So let's zoom out along the x-axis a little bit. The y-axis is okay. It was on standard zoom. So let's zoom out along the x-axis. Who knows how to do that?
You go to that tape or the window,
Window?
and then you put the numbers in.
Okay, so what do I want to put in? Well, we care about positive or negative infinity? Positive. So do we care about the left side of the graph? No, so leave that alone. So hit down. Okay, so x maximum. What do you guys want to do? What number is close to infinity that we can fit on this calculator? Okay, we can do all 9s. So tell me when to stop. Stop? Okay. 999. It's good enough for this purpose. Let's hit graph.
Nice.
See anything?
Nope.
Me neither. Let's go back to window. I think we got one too many 9s in there. Let's delete one. Let's try it again.
This is boxy. What is that?
Alright.
How about just
Let's go to window. Maybe we still got one too many 9s. Let's just try 9. Okay, so what is it doing?
Up and down.
Okay, it's going up and down, around what number?
0.
Around 0. Now when it goes up and down around 0, is it kind of going up the same distance, down the same distance, or is it getting closer and closer and closer to 0? It's getting closer and closer and closer to 0. So if it's getting closer to 0 as it goes further and further out towards infinity, what do you think it's going to eventually look like as it gets to infinity? 0. It's getting so close to 0, we're going to say it's 0. That's why we didn't see anything when we had 999. Because it's so close, can't see anything. Does that make sense? Okay, so the sign of x over x as x approaches infinity is equal to what? 0. Okay, everyone agree with that?
yes.
Everyone believe me? No? No? Okay, let me show you another way then. We can do it algebraically, so we just proved it graphically. So we know sine of x oscillates between 1 and -1, right? We had that problem on our horn, kind of. It goes up and down between 1 and -1. Everyone okay with that? Okay. But sine of x isn't our graph or our equation. It's not a problem. Sine of x over x is. So what can we do to this to make it look like that? What?
Divide by x.
Yeah, we can divide by x, but we can't just divide this one thing by x. Yeah, you gotta divide everything by x. So it looks like that. Okay, any questions so far? Okay, so let's find the limit of this side. Now, when x is infinity, alright, the bigger the denominator, the smaller the number, right? So, if x was 100, this number right here is pretty small. If x is 1,000, it's even smaller. If it's 10,000, it gets even smaller. It's getting closer to what number?
0.
It's getting closer to 0. So let's say we plug in infinity, which is kind of like a huge number. What do you think this would end up being? 0. So the limit of -1 over x as x approaches infinity is equal to 0. Is everyone okay with that? Okay, so let me explain it again. I'll explain it this one, because it's the same thing. Okay. Alright, let's do this. Here's a graph. 1 over x looks like this. Like that. Yeah?
Yeah.
Okay. We want to look for the limit as x approaches infinity. Right, there's an asymptote here. Which way is infinity? The right side or the left side? Right side, because this is positive infinity. So we're going super far this way. This graph is getting closer and closer to what number? 0. So that's why the limit of 1 over x as x approaches positive infinity is equal to 0. Same thing on this side. As x approaches negative infinity, the graph is getting closer and closer to 0. So close that we're just going to say it's 0. The limit as x approaches negative infinity is 0. The limit as x approaches positive infinity is 0. Alright. Does that make sense now? Yeah? Okay. So if the limit of this side as x approaches infinity is 0, and this is 0, and this is in between that, what does this have to be? 0. So this is kind of the proof behind it algebraically. When we were looking at the graph earlier, that was the proof behind it graphically. So when you're looking for the limit of something, if it's approaching a number, we just use substitution. We plugged it in and figure out what it's equal to. When it's infinity, you can kind of plug it in also. Like, you plug it in your head, but infinity times 2 is still infinity. Infinity squared is still right, and infinity plus 5 is infinity. So if infinity is on top over any number, it's going to simplify to infinity, right? Because infinity divided by anything is infinity. If it's whatever number, 20 or a million divided by infinity, infinity is so much larger that it's going to simplify to 0. Yeah?
Oh, it's like properties of infinity.
Kind of. So I mean, it's just kind of like a shortcut thing. So let's figure out this one here. It's just the problem is when there's an x on top and an x on the bottom. Okay, so we plug infinity here. We got 5 times infinity plus sine of infinity over infinity. Too many infinities. We don't know which is which. We don't know which one takes over. What do you think we can do? Okay, we can do properties of limit, or
Just split it up.
yeah, we can split it up. Let's just simplify this fraction real quick. So when we split it up, we get 5x over x plus sine x over x. And yeah, we do use the properties of limit because it's the limit of the first fraction now plus the limit of the second fraction. Question so far? Okay, what happens to the x's here? Cancel out. What do we know about the limit as x approaches 0 of sine x over x? 0. It's 0. And then there's no x here. So the limit of anything of just the number is just the number. And that should probably say 5. Okay, any questions with this example? Okay, so you want to simplify when you can. Anyone wants to comment down? Okay, try this. Find the limit of that as x approaches 0 from the right, and then as x approaches 0 from the left. You're not just going to be able to plug it in here. Anyone still working on this? Okay. So if you haven't figured out how to do it, plug it into your graphic calculator. You guys may have hated graphs before, but in calculus, graphs are going to be your friend. It's going to be a lot easier to see what's going on a graph than it is like this. Alright, so let's graph this together. From this screen, Jordan, what are press?
You press Y equals,
Okay,
then superior nationals, then 1 divided by x.
okay. Alright, could we use this window?
No.
Sure we can. Because what number are we looking at? 0, as x approaches 0. So even though it's off center, we can still use it. If you want to change it, you can go to zoom standard. But as x approaches 0 from the left, where's the graph going? Positive infinity. As it's going from the right, as it approaches 0 from the right, where's it going? Positive infinity. Any questions there? Therefore, the limit of these two is equal to what? Infinity. Any questions there? Okay, go and copy these two things down. After you finish copying this down, plug both of these equations in your graphic calculator. If you don't have a graphic calculator, and you don't plan on getting one in the next few days, come talk to me after class. It's got to be an actual graphic calculator also. It can't be your phone or anything like that. Anyone else comments down? Okay, so let's plug it in. We are running out of time, so I'm not going to ask anyone to tell me. I'm just going to do it. 3x to the 4th. Hit down to enter another equation. Alright, so when it says as x is large, what do you think that means? How large is large? Infinity. Right? Infinity. As x is approaching infinity. Now, if they're virtually the same, what should the graph look like as x approaches infinity? Should they be in two separate places?
No.
Should they be in one place? Yeah, if they're virtually the same graph as x gets large, when it goes towards infinity, the graph should start overlapping. Let's say graph. Okay, there's your first graph.
No, that's the second graph.
Or the second graph. Alright, what's wrong with this? Can't see it. So let's go to zoom standard real quick and see what's going on. So go hit zoom 6. Okay, there's your first graph. There's your second graph. Now, if you have one in front of you, it's a little easier to see, but this one has x, it looks like they're becoming one line here, right? One graph here. So as x goes larger, they're both going towards infinity. Right? So as x gets large, they're virtually the same graph. When x is small, like 0 or 1 or -1 and stuff, they're totally different graphs, right? But as x becomes larger, it's going to start looking like the same graph. If I zoomed in the graph when x is 1,000,000, you'll probably just see one line because they're overlapping.
Will they ever cross each other?
Sure, yeah, they can cross, but when we say virtually the same, they're close enough. Okay, here's the proof algebraically. If it's the same graph and we divided them, what should it equal? What? 1. Right? X squared and x squared are the same graph. If we divided them, they're going to give you 1. So if we divide these two graphs, when x is approaching infinity, when x is getting large, it should equal 1. So let's see if that's true. Let's simplify this. Let's break everything apart. Put them all over 3x to the 4th.
Wait, do you have to write limit as x approaches infinity?
You should, unless you do this. Let me show you. Unless you put this on parentheses. Right, that means the same thing. Okay, so this will cancel out. That's just 1. The x's here will cancel out. You get 1x on the bottom. X's here will cancel out. You get 2 right there. One of them will cancel out. You get 3 right there. Everyone okay with that?
Why did you do the x 3x?
Alright, let's say we plug infinity in there. Is there anything to plug infinity here into? No. If we plug infinity here, what's that going to be?
0.
0. Infinity's on the bottom. What happens when we plug in infinity here? At 3 over infinity, 0. 0. 0. We get 1.
We just plug in infinity.
Yep, plug in infinity. Okay, so you don't need to copy this down. Very, very simple. There are n behavior models. It's a right n behavior model as it approaches positive infinity. Left hand if it's approaching negative infinity. And basically, when you divide two equations, it just needs to equal 1 like we did in this example. So like in this one, all you gotta do is divide the two, and it should equal 1. There's your assignment. For tonight, yeah. How many sections are in chapter 2? Anyone know? 4. What section is this? 2. Therefore, quiz is coming up for the first and second section. Even though it sounds like it's not that much, we learned a lot in these 2 sections. Okay, so today is Thursday. Tomorrow we'll go over 2.2. Your quiz will be Tuesday.
Is it going to be any trick search?